this video, we will learn about override control system. Override control or selective override is one of the application of selective control. To have a better understanding on the reason override control is applied, let us understand the limitation of a conventional control system. In this diagram, we will demonstrate the limitation of a conventional control system with no override function. To understand the terms of process variable PV, set point SP and output OP, please feel free to watch the previous video in this channel. For this example, the speed of the compressor is controlled by single process variable, which is the compressor discharge pressure. Let us assume a scenario when the discharge pressure reduced due to increased downstream demand. When the discharge pressure reduced to below set point, the controller will increase the speed of the compressor. With higher compressor speed, the discharge pressure will increase back to the set point. Let us assume a second scenario when the suction pressure reduced due to lesser feed into the vessel. Since the controller do not control the suction pressure, the speed of the compressor will not change. This will potentially cause the suction pressure to continue to drop. In this uncontrolled event, the process will potentially trip on low suction pressure scenario. Since this is an undesirable condition, we will introduce the override control to overcome this problem. For an override control system, the speed of the compressor is controlled by a low selector. Override control system will typically consist of two process variable controlling one output. In this example, the first process variable will be the suction pressure, which will be controlled by the suction pressure controller. The second process variable will be the discharge pressure, which will be controlled by the discharge pressure controller. Let us assume the first scenario when the discharge pressure reduced due to increased downstream demand. When the discharge pressure reduced to below set point, the discharge pressure controller will increase the controller's output. At the low selector function block, the low selector will compare the output from both the suction controller and discharge controller. Since the value of the discharge controller's output is still lower between the two output values, the low selector will choose the discharge controller's output as the new speed of the compressor. The compressor speed will subsequently increase based on the new low selector output. With higher compressor speed, the discharge pressure will increase back to the set point. Let us assume a second scenario when the suction pressure reduced due to lesser feed into the vessel. When the suction pressure reduced below the set point, the suction pressure controller will reduce the controller's output. At the low selector function block, the low selector will again compare the output from both the suction controller and discharge controller. Since the value of the suction controller's output is lower between the two output values, the low selector will choose the suction controller's output as the new speed of the compressor. The compressor speed will subsequently reduce based on the new low selector output. With lower compressor speed, the suction pressure will increase back to the set point. Based on this example, we have demonstrated the advantage of an override control system. In normal condition, the selective control system will be controlled by the discharge pressure. In abnormal condition, the suction pressure will take over the control, and thus override the discharge pressure to reduce the compressor speed. The objective is to avoid unnecessary downstream process upset that can potentially trip the process unit. We are at the end of the video. Hope you find this video useful in understanding how an override control system works. Please feel free to subscribe to this channel to learn more about other engineering topics. Do leave your comments if you have any topic that you would like us to cover in future videos. Thanks for watching this video.